Wonderful, thank you. I'm glad I'm being here. Thank you very much for organizers to invite me here. It's always great to talk about blockchain, and it's even better to talk to such a wonderful audience as yourself. And before I talk about blockchain a little bit, I'm just tell you what my background is. So we run a company called EthWorks, and we do all kinds of things regarding the blockchain. We advise and help doing ICOs, we build smart contracts, we build dApps, we build custom blockchains, and we make it all beautiful with beautiful design, UI and UX. And I would dare to argue that puts us into a very nice position when we kind of see how the blockchain shapes, what are the trends, and what are the trains arriving to the blockchain station, and what are the trains leaving the blockchain station. And so, even further, before I talk about blockchain, I would like to tell a little bit about the book called Innovator's Dilemma and Theory of Disruptive Technologies. So, disruptive technologies, you heard the word disruptive, I'm pretty sure, many times. We have TechCrunch disrupt, everybody is disrupting, every startup is disrupting its industry and so on and so forth. But what is the origin of the word and what does it really mean? So the book argues that technologies go in cycles. They have their springs, summers, falls, and they land on the graveyard of technology. And that happened with many technology that you witness many of those cycles yourself. And one example would be a digital camera. And when I was much younger in primary school, the digital cameras appeared on the market, but they were very low resolution. It was 640 by 4080 pixels. So that was such a low resolution that back then on CRT screens, which were back then 1024 times 768 pixels, they still look crappy. So the cycle of digital cameras started when the technology was irrelevant. It just didn't make any sense for anyone to buy a digital camera. But then the technology progressed, and just a couple of years later, suddenly the technology was relevant. A lot of people were buying digital cameras to do their holiday photos, because suddenly it was 2 megapixels, 3 megapixels, 5 megapixels, and it was pretty fine. So we would say the technology performance, being megapixels in this case, crossed the first line being a consumer market. It was good enough for consumer market to buy. And as the technology grew, it crossed another line, which is enterprise market. So today, digital cameras are used for everything. If you hire a professional photographer, he has 20 megapixel cameras, probably a bunch of them. If you do scientific photography, you have a digital high frame rate cameras, and so on and so forth. Now, the irony of disruptive technologies is they often start in the companies that they are later reason to collapse. And so digital camera started at Kodak, which was the major reason why Kodak collapsed 10 or so years later. And then when the technology is good enough, it's become a sustainable technology. It's not relevant anymore. And it doesn't matter if the camera has 20 or 40 megapixels, because 20 pixels is all that we need. And therefore, we could say that digital cameras today are sustainable technology. In fact, nobody is buying any more digital cameras because we all have a couple of them in our phones. So we don't go to shop and buy digital camera to the photos on our holidays because the cameras that we have in our phones are pretty fine. And by the way, smartphones are another example of disruptive technology that just reached its peak and became sustainable technology. And every year, the smartphones are now just differ in the size of the screen versus the size of the phone itself. Now, the reason why I think it's super important to talk about it is that blockchain today is this very early stage. It's technology that for most of the market is irrelevant. And all the excitation with blockchain is premature, and I believe we need another 10 or 20 years to really do what blockchain will do. But what is it? What is it? Well, and again, I'm gonna delay answer to that question a little bit further, and we're gonna talk a little bit what a blockchain is. I'm pretty sure you more or less know the story, what a blockchain is. 2009, Bitcoin appears. We don't know who created Bitcoin. There was just white paper and a piece of software released, and the whole revolution was started. And what blockchain really did is have this invention of having something singular in the internet. If you put a movie on the internet, you can duplicate it as many times as you want. But blockchain, Bitcoin blockchain, is just one. Ethereum blockchain is just one. It cannot be falsified, cannot be copied. You can fork it and have a different version of it, but it's a different version. Now, blockchain introduced this distributed enforced rules. So anyone can create an account, and there are some rules that nobody can break. For example, if I create an account, I cannot spend the money that doesn't belong to me from different private key. I cannot spend more than I have, right? So those simple inventions enabled first cryptocurrency. And answering the question, someone asked the question before we started, where is the blockchain stored? The answer is every single full node is storing the whole blockchain. And everybody can emit a transaction, and according to the rules, if you cheat, you get forked. You get into alternative reality that nobody else cares about. But the very simple way to think about blockchain is it's simply a big, huge spreadsheet, and in case of Bitcoin, it's just a history saying Ali sent to Bob 15, let's say, Bitcoins. Then John said to Anne 3 Bitcoins. And Bob sent to Ryan for the Bitcoins, and that particular transaction would be invalid if Bob had only 15 Bitcoins. Easy peasy. Now, if you think about it, of course, people on the blockchain are public keys, so that's a little bit different. Of course, we don't know which key is Alice, which is Bob, but that's not very important for now. Now, that was Bitcoin. Now we're going to talk about huge improvement over Bitcoin, which is Ethereum. So Ethereum started with very similar notion. So we start with a blockchain. We start with a table, call it global spreadsheet. And we have transaction from to an amount of value we can send. The difference is this last field is now generalized field. Let's call it data. And in data, we can send some value. That's fine. We still have public keys. They are a little bit different format than Bitcoin, but that doesn't matter really. What was new is new kind of transaction was created. And you can see that's the third one from the top. We created a transaction that is being sent from someone to nobody, to the network in general. And it contains some amount of computer code. Now, this code is going to be put on the blockchain and stored there, and it's going to get its own address, the same way I or anyone here in the audience can have an address. Now, once we have that, we can do yet another type of transaction, which is doing a method call. So we can send transaction to this piece of code that now has its own address, and we can say execute a piece of code and give me the result. Okay? So let's just repeat. In the Ethereum zoo, we have now two types of animals. We have wallets, like we used to do in Bitcoin, and we have contracts. And we can send money back and forth between all of those. We can send from wallet to wallet, from wallet to contract to wallet, but also from contract to contract. And some of the transactions will be money transactions, or value transactions, or token transactions, and some of them is going to be execution of computer code. Here is a slide for people with computer science background. So the contracts are basically object-oriented objects in terms of object-oriented programming. They have their own store of information. They can execute code. They are fully deterministic. So every single time we run a code on every single computer in the world, it's going to give exactly the same result. And it's Turing complete, meaning you can pretty much write anything. You can write anywhere. You can write on Ethereum as well. Ether is the cryptocurrency behind Ether, and you pay with gas, which is just which you just buy with Ether automatically. So to simplify, you buy with Ether execution, storage, and everything else you need to do, because otherwise you could do infinite amount of execution and store infinite amount of information. So that's Ethereum. Now one could ask, why do I care? Okay, that's a cool piece of technology, but I mean, what do I do with that? Well, the answer is anything. Imagine Kuba. Hey, Kuba. So I'm writing a contract. I'm putting it on the blockchain, and here, there is Kuba, and here is I am, and I send a little bit of the money to the smart contract, and Kuba is sending a little bit of the money to the smart contract. Now the contract picks at random one of us and sends all the money back to that person. Might be me or Kuba, with equal probability. Can we do that? Yeah, okay. We can do that. It's very simple smart contract. It takes like, I don't know, 10, 20 lines. So this smart contracts, what we just did is we built a lottery on blockchain. Just like that. We can easily generalize the contract and say everybody in this room is chipping in 1 Ether, and then everything is being transferred to the one winner. Or we can make more complex. There might be one winner, some secondary prize, and so on and so forth. But look at all the things that we're not doing. Look at all the regulation we don't need anymore. For example, in Poland we have Lotto. Lotteries are heavy regulated markets. You need a license to run. In many, many countries, including Poland, it's a monopoly. And there is a special commission checking every single instance of a lottery happening, and so on and so forth. While, well, with this, and this all because we don't trust the guy who runs the lottery, that every single time it's either he wins, or his brother, or his mother, or his wife, or his friend, or friend of friend of friend, right? But we don't need all that. As long as we can see the code, and we see the code is fair, we can build a lottery on the blockchain, and there's a bunch of lotteries already running around on Ethereum. Okay. How about we make it a little bit more interesting? Tomek talked about prediction markets, right? So me and Kuba put some money into the contract, and depending who wins the match tomorrow, let's say Poland-Germany is playing, it's either Kuba or me that gets the money. Yeah? How we do that, how we get the information, you already know if you've been on Tomek Talks, right? You need to oracles, you can have voting, you can have staking, different strategies. But see how simple it is. How much simpler it is than running a bookmaker. Okay. Enough with the gambling. So let's bet. Enough with the gambling. Let's bet again. So this time we all chip in. And we says, if one of us has a fire in the apartment and he needs money to renew the apartment, then the smart contract will release funds. Again, the question is, how do we know if the fire really happened? And there's a bunch of different answers for that, but we just built insurance company on the blockchain. Now, insurance companies are extremely complex organization with tons of regulations all the time being changed and so on and so forth, and different audits and things happening. We don't need to do that all. We can make it something very simple in the smart contracts, or we can put all those rules to be fully compliant with the legal law, with a given jurisdiction law. We can put all the rules on the blockchain, and suddenly, instead of thousands of people, maybe we need just a couple of people to run the whole lottery. By the way, everything is on blockchain and transparent. So if anybody has any question, if the insurance company is run in a proper way, they can go to the blockchain, analyze the data, and see what happens. And so if you go from industry to industry, you can see that almost in every single industry, there are some opportunities where you can optimize, where you can change, or you can redefine how the things are being done in this particular industry. And here is my prediction. I believe that the same way internet redefined how we communicate with each other, blockchain will redefine the notion of trust. We're gonna get rid of those huge, well, maybe not get rid of, but we're gonna have new competitors for those huge, complicated organizations in almost every field. And there's gonna be a little bit more philosophy now, and then we're gonna go into more technical stuff. So what is the historical meaning? What we're trying to build, we as a blockchain community. So to understand what are the big breakthroughs in the history of humankind, one have to understand that every epoch was first initiated by the discovery of fundamental technology. So when we initially were hunters and gatherers living in very simple societies. And it was the invention of writing. It was the new way of communicating that enabled the new epoch, which was farming. Now, writing was pushing the civilization through, the writing was pushing civilization through the farming all the way to the bureaucracy, because writing enabled bureaucracy, and we were able to do debts, we were able to tell this guy earned this much for being in the army, and so on and so forth. And interesting thing is, if we think about it, that civilization was in the same point 2,000 years ago and 200 years ago. And it was only the next big innovation, which was the print, that was discovered a little bit more than 200 years ago, that enabled enlightenment. And we as the civilization accelerated like never before, and all the different innovations like steam engine, cars, planes would follow. And now we are lucky enough to live in the times where the next big invention was made, which was the internet, which enabled global communication at the scale that was impossible. And now every year things like schools and studies are becoming more and more irrelevant, because they provided with outdated knowledge that was up to date 10 years ago. But the world is changing faster than ever. And I would argue the next big invention is blockchain, because it will enable trust on the global scale. The same way we had communication at the global scale. Now we will build new thing, which is trust on the global, in a decentralized manner on the global scale. Good. So that was philosophy. Now let's talk a little bit more about technology. So you know a lot about tokens now, because Tomek talked about tokens, what it is from the economical perspective. So I will just tell a little bit more about it from the technical perspective. So token on Ethereum is nothing else than just a smart contract. A smart contract that has a list of all the different addresses, public addresses, and the values attached to it. Same way, very similar table to what the cryptocurrency itself is that we've seen before. Now, the difference between token and cryptocurrency is the token lives on Ethereum. So if you have Ethereum wallet, you can store all the Ethereum and all the different tokens. And it utilizes Ethereum infrastructure, meaning that you don't need your own miners, meaning you don't need your own super programmers that are very skilled in networking, very skilled in cryptography, and so on. All you need to do is write a simple smart contract. And by the way, those smart contracts tend to be 50, 100, 150 lines of code, still not very complicated. Now, the tokens enable creating this new, very quickly, the jump from cryptocurrency itself to the token, from technical perspective, is just, you can do it really easy. You can do it really quickly. And I think interesting thing about, if you think about, say Ethereum, how Ethereum was created, is there was just a bunch of guys, including Vitalik, and they said, we have this idea for this new kind of blockchain, and we need money to build it, because it's going to be 20, 50 highly skilled people working for a couple of years to build it. So they say, okay, here are some tokens, here are some ethers. Back then there were, no blockchain, no Ethereum blockchain yet. So you pay us some money. In that case, it was bitcoins. You pay us some bitcoins, and we'll give you those tokens. Not now yet, because, well, we don't have them yet, but we'll give you those tokens in the future. And what they get in return, they get bitcoins that would allow them to work on Ethereum for a couple next years. And that process of exchanging the future tokens, the future cryptocurrency for the funds is called ICO. So who heard about ICOs before? Come on, really? Just a third of, okay. So ICO is becoming like a huge thing over the last 2 years, and the idea is you can do your fundraising through selling tokens that will represent something in the future, something that you describe, something that you promise to deliver. And yeah, that became pretty big. So last year, in ICOs were able to raise over $5 billion, which was couple times the amount of money that was invested in Bitcoin projects and all other fundraising methods, including ICOs. Right? So I think there was $400 million VC investment in 2017 in blockchain startups. In the same time, there was over $5 billion investment, tenfold. And in 2018, and it's not even a half of a year, we already seen $6 billion, equivalent of $6 billion invested in ICOs. So that became really big thing, and it became a real competitor to other ways of doing fundraising. Now, there is a shadow over ICOs. Because what happens with ICOs is people say, yeah, we want to build this. They describe what they want to build, then they raise money, and they have the money. So the big question comes, will they be able to deliver? And with so many startups raising so much money, oftentimes raising more money than they would ever be able to raise from any VC or any other with any other fundraising method, the question comes, will they deliver? Is it legitimate at all? And so I would argue that we are in the middle of big ICO bubble when it's too easy to raise money via ICO. And one could ask a question. So is it worth joining blockchain community? Is it worth doing ICO? Is it worth investing in ICO, and so on and so forth? What is the future of the blockchain if we are in the middle of the bubble? Well, thankfully, it's not the first bubble in the history. And thankfully, it's not even the first bubble in the history of IT industry. Who knows a saying, let's party like it's 1999? Come again? Never mind. So just a couple of people, so maybe you are too young or something else is going on, but we remember the dot-com bubble that happened around the year 2000. So there was a saying, let's party like it's 1999, because people were raising crazy amount of money through VC investments or all kinds of investments to build internet companies. And there was even one startup in 1999 that would do an IPO initial, that would go public without having it from his couch in the living room. There was literally one guy running a company doing an IPO, and it was in 1999, and soon in 2000 the bubble would burst, and 99% of the companies that would raise crazy amounts of funds, not that much in comparison to ICOs these days, but still crazy amounts of money for all kinds of different businesses, they all went bankrupt. How does it sound? Does that sound good? No, that doesn't sound good. Well, but there are some companies that survived. There are some companies that survived the dot-com bubble. Here is randomly chosen 5 companies that survived dot-com bubble. And Zappos, I read the story about the guy doing an IPO from the couch in the biography of the Zappos founder. And he says in 1999, when they realized what's going on, they said, we really need to raise funds fast because it's about to burst, and it's the last moment we're gonna get any funding for the next couple of years. And that's what Zappos did. Google, on the other hand, so Larry Page was picking up girls, saying he's a startup owner, and then in 2000 he realized that it doesn't work anymore after bubble burst, and that's how Google Apps was born, because they realized they actually need to make money. They cannot just live out of VC investments. Well, in 2003, there was a huge impact done by one article about Amazon, who says Amazon is losing money and is losing money fast, and it's all a scam. 2003, 3 years after the bubble burst. And yet, those are the companies that change the way we do things and change the way we function. And by the way, Zappos was bought by Amazon. It was the second biggest retailer in the world before the acquisition. You might not know Zappos. It was not operating on European market. So the question comes, if we are in this 90s of blockchain, how can we build a business? How can we reason about blockchain? What is it that we can do to make an impact, to use the situation in the right time and the right place? You are in the right time and the right place now, starting to understand something big that's going to happen over 10, 20 years, hopefully, if I'm right, and a bunch of guys who were talking before me as well. So let's take a look at Netflix. So Netflix was founded in 1997 with obvious idea to deliver the content, the video over the internet. By the way, in 1995, there was a book written by Bill Gates, and the name of the book was The Road Ahead. And he says, internet gonna change everything. Everything we do, we're gonna do over internet. We're gonna learn over the internet, we're gonna watch movies in the internet, we're gonna listen to radio in the internet, we're gonna learn everything in the internet. And it gets like 3 stars on Amazon out of 10, a couple of years later. And it was 1995 that people knew what's gonna happen. Like there's a bunch of those people, a bunch of those companies, they knew the internet is gonna change everything. But then still we went through the dot-com bubble burst, and then took another couple of years to get to Web 2.0, and then, it takes, things take so much longer than people predict. Everything is so slow, really, and that's what people don't understand in general, but in context of blockchain, I think. So in 2007, there starts streaming service, 10 years later. In 1997, they're sending DVDs to mailboxes, to not email, to mailboxes. So you can go to the website, you can say, this weekend I would like to watch this movie, and this movie. And the next day it's in your mailbox. When you finish watching after the weekend, Sunday evening you put it into the mailbox, and Monday morning someone picks it up. And that's how they were functioning for 10 years before the streaming was there. It takes 10 years. Now, 3 years ago, my friend is working in YouTube. 3 or 4 years ago, he says to me, if you want to do a video advertising startup, the time is now because the bandwidth is finally there, right? So from 2007 and streaming, it took almost another decade to get to the coverage when everybody has a good enough internet connection that they can actually watch high-quality movies, right? So 2 decades. So from sending DVDs to streaming a decade later, but in 2010s, when we discovered that streaming is possible, everybody is doing streaming now. Apple is doing, Google is doing, HBO is doing, everybody is doing streaming. How do you win with those guys? So this idea that was so sexy, so cool in 1997, suddenly is irrelevant because everybody can do streaming. But along the way, they discovered something that other companies couldn't do if they wouldn't go that path. They discovered they have all the data about the users they need. They understand what people want to watch. And they are in completely different game now. Their end game is not streaming. The end game is content production. And if you go to Netflix website, there is a form you can fill, and you can describe your idea for the TV series or the movie. And there's a scoring algorithm that will say how much money will the movie earn based on your idea, on one form. And here's an interesting thing. this form was filled by someone with the idea to do a TV series that was later called Narcos, and the algorithm said, it's a very good idea, that should be low-budget production, and should be released in South America. And so the Netflix did, and the movie was a great hit. The TV series was a great hit. They re-entered the similar data a couple years later where the market changed, and they said, and the algorithm says, yeah, it's a good idea, but let's make it a high-budget production and release on the North American market. And that's the Narcos that I'm pretty sure at least some of you have watched, right? So this is really happening. This is like the things we watch. It's scored by the algorithm, and that's how decisions in the Netflix are made, and that's their end game. So I think the same is the case for the blockchain. If you look to do X on the blockchain, you should first look into how you would like to have it in 10 years, but today you need to do something simpler because it's not possible yet. But that ain't gonna be your end game. Whew, that was a lot of philosophy. Who want to see some code? Bam, a bunch of people want to see some code. Okay, so, smart contracts. Here is a very simple smart contract. I would call it a hello world of smart contracts. So, as I said before, imagine you have, imagine a contract is basically an object in object-oriented programming. Contract has its store, values that it stores, method functions, if you prefer, and contracts can deliver from contracts. There is one global space of all objects, of all contracts on Ethereum, so every contract can call method on any contract globally. And so we have our first contract, which is Mortal. Mortal happens to be the contract, the one that you can kill, because not all the contracts can be killed. So Mortal has an owner. Owner is a type of address, meaning that it's an Ethereum address. And Mortal has a constructor, which is called Mortal, the same way as a contract. And the only thing we do in the constructor is we store the information who was creator of the contract. So we store in the owner variable, we store message.sender is always the value of the person who initiated the transaction that led to the execution. And in this particular case, it's constructor, so it's the person who initiated the deployment of the contract. Now there is a function kill that's gonna destroy the contract. And just before we're gonna destroy the contracts and we're gonna remove it from the memory of all those people who are storing the node, we're gonna check if the person calling, in this particular case, is the owner. So only the owner can kill the contract. Only the guy who deployed the contract can kill it later. Good. Now, we have a greeter. Greeter is a mortal, so can be killed, and greeter has just one, has a constructor that just stores the information about what is the greeting. And then if we ask him to greet, then he will return the information. Even such a simple smart contract can be useful to leave information for your friends on blockchain. Or if we remove the mortal part, it's gonna stay there forever. So it's like, putting something in stone, in very, very big stone. So that's a very simple contract. Do you have any questions about the contract itself? Good. So we're gonna do something more complicated. So I talk a little bit about how blockchain is gonna redefine the global trust. So let's say, who is willing to join me in this presentation? Rafa, would you? Okay. So let's say Rafa wants to buy something from me on the internet. He don't know me, and we have no trusted third party like eBay or Allegro or anything else. Let's say it's something we don't want to know about, just between the two of us. It might be some kind of drugs, but might be something completely legal too. So here's the game we're gonna play. So I'm gonna say, I'm willing to sell, let's say the bottle, I'm willing to sell this bottle to you for, let's say, well, how much it's worth? Let's say 1 Ether, okay? And what I'm gonna do is I'm gonna put 2 Ethers, not 1, but 2 Ethers into the smart contract and say, I'm willing to sell this bottle And these 2 ethers is going to be for me to show I'm serious about it. I'm seriously want to sell it, because I wouldn't lock 2 ethers that I can get totally wasted with to just lock in a contract and do nothing, right? And if you, Rafa, would like to buy it from me, what you're going to do is you're going to put 2 ethers in the contract as well to show that you are serious about buying it. And now I'm going to send it over the mail to Rafa. And when it arrives, Rafa says, I got it. It's there. And then he's going to say the transaction was successful. And I'm going to and he's going to get 1 ether back, because he locked 2 ethers. 1 ether to show he's serious, and 1 ether for me. And I'm going to get back 3 ethers, because 2 ethers to show that I'm serious, and 1 ether for the battle. Does that make sense? Easy?
What if he says he didn't receive it?
Well, then he will not get his 1 ether back.
What if you didn't send it at all?
Then we both won't get our 2 ethers back. That should make us pretty motivated to actually perform the deal.
Like blockchain in general is based on incentives.
Exactly. So assuming incentives have this property, they only work if we assume the actors act reasonably, right? If someone wants just to lose a lot of money, as long as other guy is losing money, it ain't gonna work.
What will happen if the boss lost your battle? Really deliver it, then you will be...
Well, I guess you need to send another one. Because I don't think Rafa is confirming if he's not getting there. I'm calling him and saying, it's a post. And he's okay, send me another one. I will confirm. That's what I would do. Rafa, would you do that? Yes. He says yes. Good? Are we ready? So this is a smart contract. There's going to be some additional code on the second slide, but this is the core of the smart contract, right? Can I, for example, can we have like a laser or something? I think it's going to be much easier. Which one? Good. So we have a purchase contract. Purchase contracts have integer value that is, well, unsigned integer, but I guess it's not that important, that says, okay, this is the value, let's say 1 ether. It has address of a seller, me, and address of a buyer, Rafa. And it has 3 states, so it just freshly created. It's been locked and it's inactive. Locked when it's waiting to be fulfilled, for the purchase to be fulfilled, and inactive if it's done and not used anymore. And we have a constructor. Again, the name of the contract is the same as the name of the function. We store the information who the seller is, so I'm the seller. We store the information what is the price, so I'm sending 2 ethers. Message value is 2 ethers, so division by 2, so 1 ether is the value. And we're checking if one to the 1 decimal point is not being lost, because that's, that would be money lost. Not a lot though, because Ethereum has 18 decimal places, so that's 1 divided by 10 to the power of 18. So that's very little money, but still. And so that's me deploying the contract saying, I would like to sell the battle. Now we have a confirmed purchase, which will be called by Rafa once the battle arrives. And it needs to be in the state created, so only freshly initiated contract will work. And, sorry, I ran too fast. Rafa is now saying, confirmed purchase means, Rafa is now saying, I'm willing to buy a battle. I'm willing to buy a battle. And it's only a fresh contract, and he's sending the same amount of value that I did to the contract to be locked in the contract. So this is now stored in the contract, and this is now stored in the contract. So after the confirmed purchase is being executed, 4 ether is stored in the contract. And we say payable, and payable here, that means the money can be transferred to the contract with those methods. And all the contract is doing is saying, okay, Rafa is the buyer, and now we move to the state locked, meaning, we're waiting for the purchase to arrive. And once the purchase arrives, Rafał can call confirm received. Only Rafał can do that. I cannot confirm for myself. Only in state logged, so only when we are actually waiting, and we say, okay, we are done. The contract is now inactive. We transfer buyer value, so Rafał gets his 1 Ether back, and I get all the rest of the money, which happens to be 3 Ethers. Do you have questions? If the seller doesn't have the money, so you mean here?
What if the seller doesn't have the money to put this in transaction? If I understand correctly, you said that both seller and buyer should have 2 Ethers.
Yeah, so in this method, purchase, when he creates a contract, when he's deploying the contracts for the first time, he sends some Ether along with that. And the amount of Ether that he sends is in this message.value variable. So when he creates a contract, he sends 2 Ethers, so the contract knows the value is 1 Ether. If he sends 2 Ethers, if he sends 10 Ethers instead, then the value is 5 Ethers. If he sends 0.00005 Ether, then the value is 2.5. And Rafał will only join if he sends the same amount of value. So when he sends the same amount of value, he agrees that that's the value we are dealing with. And there are some little details about our implementation. So we've been using these helpers, only buyer, only seller, in state. Those are just like, they call function modifiers. They are just like additional things, additional lines you can inject into methods. We also use this condition modifier. So that's just a syntax sugar, doesn't really matter. But you can see, for example, only seller require message sender to be seller. And if we go 1 slide back, only seller is used, well, only buyer in this case is used here, right? So that just inlining the function. Mm-hmm.
How is concurrency dealt in this?
Let's wait for the mic. Mm-hmm.
I'm wondering, how is concurrency dealt in this situation? About abort, for example. If
that's an excellent question. That's an excellent question. That's a very, very good question. So it happens that every single method here is called we could think about it as a database transaction. So either the whole method will succeed, either the state will be like the method was never called. And in particular, you can see the require here. So the contract will not be successfully deployed if this condition, if the number is odd, the amount of money that we send is odd, the contract will never be deployed. In the same way, here, if only buyer requirement is not met, the method will fail, and the state will be like the method was never called. In particular, those transactions are being emitted to the network, and they're being gathered in their mempools by miners. A miner order the transaction and execute 1 by 1. That's why they kind of look like. There is global order of execution in Bitcoin, in Ethereum, and every single blockchain.
But it's not like that, right? There's nothing like global order of execution. I think, if I understand that correctly, it all depends on how much gas you put in your transaction, right?
Mm-hmm.
So the more gas you put in your transaction, it will be picked up earlier by the miners, right?
Excellent point. Like the order is only established after the block is mined. So when you emit the transaction to the network, you don't know when it's going to be mined. But once it's going to be mined by a miner, the state is established. The state is updated after every single block, and then the order cannot be changed. Does that answer both of your questions?
It introduces some more.
It's game. It's like a game with rounds. You remember those paper games with with artifacts, and then there is one round, and player can do a couple of moves, and within the round, between the rounds, they can move as many as I want, but then we close the round, we check if they didn't break any rules, if everything is okay, that's the new state of the game, and then another round starts.
So single node takes all of the transactions. Let's focus on single node for a moment, right? So it takes all of the transactions, it mines block, which means it puts all of those transactions in single block, and the order is being settled, right? And this is only one node, right?
So it's very important. First, the transactions are transmitted to the network and being pulled by miners. And only one miner will win a global competition to be the guy who puts the next block in top of blockchain. And only when he does, and all the other people will download the transaction back with the block, is when the state is stable.
So what you're saying, we have a common pool of transactions, and like every time, only one miner can create another block.
Exactly.
The next block.
In Bitcoin, in Ethereum, and everything, there is, by fourth presentation on blockchain, you should know that. So we definitely lose something else, but we need to understand this part. So what happens, there is a global competition going on every second, right now, for every single big block mining blockchain like Ethereum or Bitcoin. And the miners all around the world compete to be the next one who will produce the next block. And only one will win for this particular block. And this guy will tell what the order of transaction is, whether it's Bitcoin or Ethereum, whether it's just money transaction or code execution. And this guy will get reward. And they are in global competition all the time, earning money, participating in pools, and the whole mining is like, you could do literally like a full university lecture only on mining, how it works, and hardware and software and strategies, and economics of that, and so on and so forth. But essentially what you need to know is there's this delay. I propagate transaction, and only when it's going to be mined, I know that it succeeded or failed.
So the competition is called mining, or creation of new block is called mining?
Creation of the new block is called mining, and it's the product of global competition.
But it's like single step. So whenever I want to know who will be the next miner who creates a block, so they compete with some mathematic problem.
And just one is the winner.
So one guy comes up with the next hash, basically, and this guy will get all of the transactions
ordered. He decides.
Yeah, but don't you need like a payload for the next transaction, for the next block to generate new hash?
They gather payload all the time. They gather transactions.
Okay.
Let's stick with that because we have 2 more minutes. So I would love to answer all the questions later. So I just want to say the blockchain is the tip of the iceberg. There's like a whole ecosystem being built right now with oracles that Tomek mentioned before, with distributed file systems, because storing a simple. So we had this competition. We had this hackathon last weekend, and the guys want to store a Lamborghini picture on Ethereum. And storing high-quality Lamborghini picture on Ethereum would be more expensive than the Lamborghini itself. So for those things, our distributed file storage, tremendous amount of research going on there, and we're looking forward to IPFS working today, Swarm being in the testnet, very interesting stuff. We need stable coins, because if we want to insure our flat, we don't want to do it in Ethereum that is going like this. We want to do it in Euro, PLN, USD. So stable tokens that represent stable coins. Technologies for better communication between the nodes, that's Whisper. And we have tremendous amount of research regarding scalability. So we have, like on our first presentation of NEO, if someone was attending, we have only 5 to 10 transactions, 10 to 20 transactions in Ethereum network per second. That's far from what we like to do. So we have state channels, sharding, plasma chains, all kind of different strange words, but behind each of these there is fundamental mathematical research about building something more scalable. We have ZK snarks that will enable currencies that are anonymous, so you'll be able to pay for it. Nobody will know how much money you have. Even you won't know until you have a private key, but you'll be able to pay with that money, but no more than you have, and only with your own money. So this is really complicated mathematical and cryptography research going on there. Proof of stake that Tomek mentioned before is also a very important piece of research happening. So these all things, or at least some of them, we need to build those final game businesses in a decade or two. So to summarize what we're trying to do, what we're kind of trying to do is build a new model of cooperation. So Web 1.0, before the dot-com bubble, it was like client-server architecture. If you read magazines 2 decades old, maybe someone here is that old. I'm not that old, but I was just 10 years old when I was reading those magazines and IBM advertisement. Everything was about client-server. So, and there was, people would do their websites and do their shops on the internet. Then Web 2.0 came and said, yeah, you don't want to do your website. You don't want to build your shop. We have Shopify for that. We have Facebook for your personal presence online, right? We have all kinds of platforms. So Web 2.0 was all about platforms and all about cloud. Is all about platform and all about cloud. And it's made tremendous acceleration. And nobody is anymore like set up in your own blog unless you're a developer and you have too much free time. Everybody is doing Blogger, Medium, whatever, right? So what Web 3.0 is trying to build is this new third model. This is the game. This is what we're looking at, the final game in a decade or two, when the technology is there, when we figure out business models and everything. We want to build something that is not connected to the servers anymore. It's something that you have a piece of that on your computer, and then you're able to interact with other people and build all those different social and economical interactions. And yeah, I think the time is up. I have one more slide, but I think we're fine. We're fine for now. Thank you very much. If you have more